Hey pre-calc students, these are the notes for recursion. So the only notes for the week. This will help you out not only with your worksheet for recursion, but also for your recursion project that you're going to be doing later on this week. So you'll want to grab your notebooks and follow along just like you normally would. Make sure you're pausing if you need to and listening to my voice, otherwise you're going to be missing quite a bit. So Unit 11, sequences and series still. This is kind of the bonus part of the unit. We're talking about recursion, and today is Tuesday, April 25th. And first thing we have here is just kind of the formal definition of recursion. Recursion is the process of finding a term in a sequence by using one or more of the previous terms. So we're still talking sequences. We're just not necessarily talking about geometric or arithmetic sequences. We could be. We could use recursion for those things as well. But a lot of times recursion equations are used when it doesn't make sense to use arithmetic nor geometric sequences. So we'll start with probably one of the most famous sequences there is. Maybe you've heard of this before, maybe not. You can Google it, and there are all sorts of real-world implications for the Fibonacci sequence. And the Fibonacci sequence, it's really simple. What it does is it starts with two ones, and then from then on, to get the next term, you're going to add the two previous terms. So to get the third term, we're just going to add 1 plus 1, and we obviously get 2. And then to get the next term, we would add 2 plus 1, and we would get 3. And then we do 3 plus 2, which is 5. And 5 plus 3, which is 8. And we could go on like that forever and ever and ever. Okay? So we're not adding the same number each time. We're not multiplying by the same thing each time. So it's not arithmetic. It's not geometric. But it's obviously still following a pretty simple pattern. Okay? What we're doing, I'll just start with an easy one here. To get the third term, so to get that third term, we need to add the second term plus the first term. Okay? Well, in general, what we need to do is we need to, so I'm going to do the general a sub n, we need to get the term before it, so that would be n minus 1, and then we need to add to it the term that was 2 back, so that would be n minus 2. Okay, and that's going to work however far out we go. Now, we need to have a starting point, so when we do these recursion equations, we need to tell people where we started. We got to tell them the first term is 1, and in this case, we also have to tell them the second term, because the pattern doesn't really start until we have those first two clarified. So the first term is 1, the second term is also 1. From there, in order to get any term, you need the two terms before it. So the drawback with recursion is that you can't just magically go find the 100th term. In order, in this case, to find the 100th term, so say we wanted a sub 100, we would need the 99th term, and we would need the 98th term. And there's no way to find those unless we are using recursion to find them. So you're going to find out that we're going to use a lot of Google Sheets to list the whole entire sequence, and the TI-84 calculator can do the same thing. So those are the drawbacks, but it's powerful in the sense that we can do sequences that aren't arithmetic nor geometric. Okay, so we'll get into some examples here. This first one says use the recursive equation to find the first 5 terms in the sequence. They give us the first term, and then they give us the general equation. Now, you're going to notice with recursion, instead of using a, they're going to use u. That's how your graphing calculator is going to be set up to use, so we'll stick with u's. If I accidentally use an a, that was an accident. We really should be using a u at this point, just to stay consistent. So, I'm just going to do this one by hand, just to make sure we have the hang of it. So the first term is just 10. That one's easy. They tell us that right here. The second term, we have to follow our rule now. So our rule says take the previous term, so that's the n minus 1, previous term, and then add 6 to it. So we're going to take the 10 that we already had and add 6 to it, and we're going to get 16. And then the third term is going to be 16 plus 6 more, which is 22. And then the fourth term is going to be 22 plus 6, which is obviously 28. And then the fifth term, 28 plus 6, which is 34. Now, this one is an arithmetic sequence. All we're doing is adding 6 each time. So it probably would have been a lot easier to just use an arithmetic sequence formula. If we were going to find something way, way out in the distance, like u sub 100, using recursion, we would have to find all 99 before that, where with the arithmetic formula, we could just go ahead and find that 100th term. Okay. And then we are going to do this. I'm going to show you how to use the calculator on this one again, in case you still need to see that, and Google Sheets as well. So I'm going to flip over to those, and I'm going to type here. I'll do Google Sheets first. So I'm going to type in a 10. That was our first term. Then I'm going to hit equals, click on that term above, and then add 6. And Google Sheets is using recursion. That's what it's always using. It's taking the one above and doing something to it. So once you click enter and then you click and drag, it'll do that for you. So there's our 10, 16, 22, 28, 34. Okay. Then a reminder how to use the TI-84. You're going to want to go to mca.ardale.org. That'll take you to this page right here. A little different than it used to be. Click preparing for testing. Scroll down to standalone calculators. Grade 8 and 11 graphing calculator. It's kind of a lot of clicks to get going, but once we get there and we hit the calculator, there we go. Okay, so first thing you want to do is hit mode, go down to where it's currently on function, and then go over to sequence, hit enter, hit second quit, or you can just go right to y equals. We're going to start with n minimum equals 1 because they gave us the first term. And then this is where we type in our actual formula here. So we're going to do second 7. That gives us the u. And then we need parentheses n minus 1. The n is this xt theta n minus 1. There we go. Close that up. And then plus 6. And then we got to tell it that the first term was 10. And then hit enter so it makes sure it saves that. We don't care what the second term is. It's 16, but we don't need to do that in this case. Hit second table, and there is your list. 10, 16, 22, 28, 34. We get the same exact thing. So I think it's useful to practice with the calculator a couple times just in case something like this were to come up on like an MCA or an ACT or something like that where you wouldn't get to use Google Sheets. So it's a tool that we can use. A little more clunky, but it works. All right, example 2. So this is a situation where recursion is actually necessary because the first term is 55, and then after that, there's two things that are happening. The term before is being multiplied by 1.05, but we're also subtracting 9. And I don't really want to do this one by hand for too long. Maybe I'll do the first one, but after that it's going to be kind of a lot of work to do it by hand. So I'll just do one so we got the idea. First term is 55, and then after that, to get the next term, we need to take the term before, which was 55, and then multiply that by 1.05, and then after that subtract 9. So I already went ahead and did that on my calculator. 55 times 1.05, take away 9, ends up being 48.75. Okay, the better way to do this is to use either Google Sheets or the graphing calculator. This one I'm just going to use Google Sheets. So I'm going to hop back over there, and I'm going to type in 55, which is the first term, and then equal sign, click on 55. You got to tell it you want to multiply, so you got to do Shift 8 for the multiplication sign. Then you can use parentheses or not, it doesn't matter. I'll just not use them. 1.05 minus 9. Hit enter. There we go. There's the 48.75 that we had before, and then we can drag that down, and you can see what's happening with that. Okay, I'm not going to do it on the graphic calculator this time. I'll maybe flip back to that one on a different example. Alright, moving on to example 3. This time we're supposed to give the recursion equation for the sequence. So we have to figure out what the pattern is and then write the formula. So it looks like this one's going to be pretty simple. It looks like we're just subtracting 5 each time. Negative 3 minus 5 is negative 8. Negative 8 minus 5 more is negative 13. So it's an arithmetic sequence. We could write it as an arithmetic sequence, but it doesn't want us to. It wants us to use recursion. Okay. So what we first need to do is we need to write down the first term. That's important. That's what people sometimes forget to do. We got to tell the world what our first term is. Otherwise, we would have no idea where to start. Okay. From there, now we can tell everybody what to do. So what we do is to get any term, we need the term before it minus 5. So it's simple. It's just the term before n, so n minus 1, and then take that and take away 5. And that'll work. I don't think I will spend any more time on that one. We'll go on to the next one. This one looks a little bit more complicated. We have 30 and then negative 22.5 and then back to positive 16.85. When you're bouncing back and forth between positives and negatives, that's a pretty good indication that it's geometric, that you're multiplying by something. And we're not going to give you anything too crazy hard here when you're trying to write your own recursion equation. So I think what's happening here is maybe we're multiplying by, I think it ends up being 3/4. If you can't quite see that, my suggestion there is just to divide backwards. So if you did negative 22.5 divided by 30, that's going to give you negative 3/4 or negative 0.75. Okay, and you can try it here and it does work. If you multiply this guy by negative 0.75, you're going to get 16.875. So that's the situation. That's what's going on. So again, don't forget when you're writing your recursion equations to tell everybody what that first term was. That first term was 30. Then from there, you can say, okay, to get any term, you need to take the term before it, and then you need to multiply it by negative 0.75. Okay, this stuff isn't super difficult. It's just, it looks a little weird, and after doing the whole unit doing something else, it seems a little strange. But hopefully it'll click and won't be too bad. Okay, well now we're going to go on to using our graphing calculator again. So I said I would do it again, so here we are doing it again. So this time, the first term is 320, and then we're going to use the recursion equation, and again, it's a simple one. It's just u sub n equals u sub n minus 1 minus 16. So all that's happening is we're subtracting 16 each time to get from term to term, and we're looking for the 19th term. Okay, so again, I'll write the website on here in case anyone missed it, mca.ardale.org. And then that takes us over here. And then I'll start from scratch. So you want to make sure that you go to mode first. Make sure that you have sequence SEQ highlighted. Then go to y equals. If you have stuff in there, you can either clear it or you could just manipulate it. That's kind of nice too. If you already have your u n minus 1 in there, then maybe just leave that there. And then change your plus 6 to minus 16. So that's what we're doing in this problem. And then our first term was 320. Don't care about the second term. And then just a reminder, if you do need to get the u, it's second 7. We already had the u in there, so I didn't do it. So second 7 to get the u. All right, then hit second table. And then we want the 19th term. So just scroll down until you get to 19. And the 19th term is 32. And that one's done. And now we're moving on to some word problems. So definitely pause and get this written down if you think that'd be helpful to have in your notes. These problems are going to be helpful, obviously for the word problems in your homework, but then for your project as well. So definitely important here. It says the number of people that carpool to work has grown at a rate of 1.2% each year. If there are 2,750 people that carpool to work now, how many will there be 15 years from now? Now, this is something that is super important here. If your problem has anything to do with time, if you see time anywhere in your problem, it is a really good idea to start at u sub 0. Okay? The reason for that is if you have a problem with time, your first term is actually when 0 time has passed. Okay, we're talking about right now, 2750 people carpool to work. So we don't want any time to have passed. So that's why we're going to use u sub 0. So that's the first important part. Okay. Now after that, we want to deal with this percentage. So we did this sum before. We're doing it again. We always want to start with 100%. And then it says it's grown at that rate. So we're going to add 1.2% to our 100%, which gives us 101.2%. We can slide our decimal back, and we end up with 1.012. Okay. If you're comfortable with just using 1 to begin with, and then basically we're just changing everything to decimals right away, and then adding to that 0.012, that's fine too. We will actually do some where we're going to do them that way. So kind of plant that seed now. Okay. So then we get to the part where we get to write our equation. So to do that, let's scroll down a little bit here. Hold on. There we go. All right, so we have to define our 0 term. So our 0 term was 2,750. And then our equation is take the term before, take the year before, and multiply it by 1.012. Okay, nothing else is happening. All we're doing is increasing how many people carpool by a percentage. So we're multiplying it by that. And then I think for this one, I'll go back to Google Sheets. I'll kind of just keep going back and forth here, doing it both ways. So on Google Sheets, I'm actually going to remind myself that this is 0 time, 1 time, 2 time, 3 time, 4 time, and the time I'm talking about is years. So I'm going to start another column there and do that. And how far do we need? We needed 15 years. Okay, otherwise I think sometimes you get confused and you start looking at the numbers over on the left, and you end up writing down the wrong answer. So I'm going to do that. That's how many years have passed. And then I need starting 2750 and then equals, click, shift 8 for times. That one, times 1.012, hit enter, click, drag it all the way down. And then after 15 years, so here's our 15th year, we're talking people, so let's just round to the nearest whole number. So 3289 people. And we should add some units when we're doing those real world problems. All right, moving along to example 7. This one, they kind of get more and more complicated as we go here. Example 7, this is some cool real life stuff. You invest $400 into an account that pays 2.3% compounded monthly. How much is your investment worth after 2.5 years? Okay, so what's weird and a little more difficult about this one is we have 2 different times going on. We have compounded monthly, but then we have how much is your investment worth after 2.5 years, after 2.5 years. So the first thing I would do is I would get all of your time the same. The easiest way to do that is to multiply your 2.5 years by 12, because there's 12 months in a year, and that gives you 30 months. Okay, now our problem is totally converted into months, and that's going to be a lot easier to deal with. Okay, then this whole compounded monthly thing, what does that mean? That means that your interest gets not compounded at the end of the year, not added at the end of the year, but added every month. But unfortunately, the bank doesn't give you 2.3% every single month. That'd be really great if they did. They don't. They divide that. They divide your 2.3% by 12. This is your annual, I think that has 2 ends, your annual percentage. A lot of times you'll see APY. If you're watching like car commercials and things like that, they'll say APY. That's the percent per year. So if it's compounded monthly, then it divides by 12. The same thing would happen like on your car payment. You wouldn't have to pay that much every single month. So that's what we have to do there. So now we get into kind of getting this all together. So good news here is the bank is giving you money. Okay, so they're taking 100% of your money, but they are giving you interest on your money. So they are adding to it that 2.3%, but over 12. Okay, so what that ends up being is 100.1917%, which is 1.001917. Okay. Then, remember, anytime we're dealing with time, we should start at term 0. So we're starting with $400. And now we can finally, after all that work, write our equation. So our equation says to find any term, we're going to take the term before it, the month before it, and we're going to multiply it by 1.001917. Okay? And then we're looking for how much is that going to be worth after 30 months. Okay? So I'll go back to graphing calculator on this one. So graphing calculator, I'm going to go back to y equals. This time I want to change the n minimum to 0. That will make sure that we're actually looking for the 30th month. Otherwise we'll get confused. I'm going to leave all that in there, but then this time I'm multiplying it by 1.001917. Close that up. Starting value is 400. Make sure you hit enter after that, otherwise it won't like it. Hit second table, and we need to scroll down to the 30th. And wow, we didn't make much money. We made $23.66. So there it is. After 30 months, $423.66. So we started with 400. 30 months later, 2.5 months later, we have $23.66 more than what we started with. All right, moving on. We got 2 more examples. Unfortunately, the last one is pretty long. So stick with me here, or pause and take a break if you need to. Example 8 says, what if you invest $400 in an account that pays 2.3% compounded monthly, and you contribute an additional $125 each month? Now how much is your investment worth after 2.5 years? So this is the good thing about life and how you should do things when you have a job that gives you money, is you shouldn't just put $400 in the bank and leave it. You should keep adding to it, because if you are able to keep adding to it, obviously you're getting the interest, but then you're adding to it yourself. So that's always a good idea. Good news here is we've already done a bunch of this problem. We still know that the 0 term is 400. We still know that the bank's interest is at 1.001917, but this time we are adding our own extra money here. So that's going to look like this. Okay, we're going to take the term before, the month before, and we're going to multiply it by 1.001917. That's from the previous work that we did. But now we're adding $125 to it. So this is where recursion is really important, because it's no longer just a geometric sequence anymore. It was, example 7 was just a geometric sequence. But now that we're adding onto it, we're kind of combining geometric and arithmetic. So this is really the only way to do it. Okay, so now we can find that 30th term. I'm going to go back into the graphing calculator. And it's going to be simple. We just need to go back to the y equals, and we need to scroll to the end of this, and now we need to add 125. Make sure you hit enter after you've done that, otherwise it won't save it. Hit second table. I'm going to go down to the 30th month, and there we go. That looks a lot better. $4,279.78. So it definitely pays to add more money to your account if you're able to. All right. one quick thing I want to add to this, because this comes up in your project and it's something that people struggle with sometimes. If you wanted to know how much you actually put in of your own money, so I'm going to add here own money. Okay, what did we do? Well, we started with $400 and then we kept adding $125 for 30 months, right? 1, 2, 3, 4, 5, month 1 all the way through 30. So we did 125 times 30. So if we did that, I'm just going to grab a calculator on the side here and do that. 125 times 30 plus 400. So we actually added $4,150 of our own money. So yeah, we got a lot more interest than the $23 that we got last time. Is that what it was? But I mean, still, we put in a big chunk of that money. The bank didn't just magically give us all that money. So that's how you can figure that out. Figure out how many payments you made, what you started with, and add that together, and now you know. All right, oops, and then last example here. Again, this is kind of a long one. It's got lots of steps to it, but I think it will be helpful, so bear with me if you can here. It says the new snowmobile costs $4,200. The bank will give you a loan that charges 5.2% compounded monthly. Your payment is $150 each month. So super real life. Maybe you're not all going to go buy a snowmobile, but a lot of times students' first purchases are something like this, like maybe a cheaper car or a four-wheeler or a boat or something that's not super expensive. You guys don't necessarily have the money to buy it outright, so you're gonna get a loan with a reasonable, hopefully, payment. The problem with that is the interest is fairly high right now. This is probably pretty accurate with buying a snowmobile or a four-wheeler or something like that right now in 2023. So let's go ahead and do this. We're kind of putting together everything that we've done here. So write a recursive equation. So first thing is to remember that we need to start with u sub 0 because it's a time problem. So that's our original cost. Our original cost is $4,200. Okay. Then what's happening? Well, two things are happening. The bank is increasing what you owe, unfortunately. So the bank is taking your $4,200 and they're charging you interest on it, and it's compounded monthly. Okay. So that's the thing where I'm going to do it this way this time. I'm going to start with 1. So we're multiplying by 1. We're keeping 100%. Plus, we're adding to it 0.052, but remember it's compounded monthly, so it's not quite as bad. We're dividing that yearly rate by 12. All right, and then I have figured out that it's fine if you write it like that, and the TI calculator likes it okay like that, but the Google Sheets likes it a little better if you go ahead and convert that into an actual decimal. So it ends up being 1.00433. Okay, and that's our interest. That is what the bank is charging us. Now, the good news is that we are subtracting $150 each time. We're paying off $150 each month, and our snowmobile wasn't super expensive, so we should be able to pay this off pretty quickly. So I'm going to go ahead and just write this. Enough talking about it. All right, to get from term to term, we're going to take the term before. We're going to multiply it by that bank's interest. That's divided over the 12 months. But we are taking off $150 of that loan every month. We're paying it off, so we are subtracting it from what we originally owed. Okay? So now, if we want to know how much we owe after 12 months, if we're looking for u sub 12, then we can just grab Google Sheets or grab a graphing calculator. Whatever you prefer is really fine. I'm going to pull up Google Sheets, and I already have this one in here. I did 4,200, and then I typed the formula in there. Pause if you need to see that. Hit enter, click, drag it down, and we just need to go down to after 12 months. So after 12 months, we owe $2,580.14. Okay, so we're not quite halfway done paying, but we've got it down quite a bit. The question now is how long will it take to pay off the loan? So we want to see at what month are we down to zero? Where do we owe $0? So I can just go back to the Google Sheets. I gotta go back to where I typed the formula in. I'm just gonna drag it super far down. And then we gotta look over here. So this is where we make our last payment. And I gotta keep going with this. 16, 17, 18. Doing this the slow way. I gotta see where we're at. 27 months, 28 months, 29 months, and 30 months. So somewhere between the 29th and the 30th month is where it happens. So typically if you actually take out a loan, they're just going to make your last payment less. So you were down to $136.59. So they're going to make your last payment be that instead of the $150 that it actually was. So I would say it actually takes 30 months. You weren't quite done after 29. It took 30 months. And then your last payment was smaller. Your last payment was 136. What was the decimal there? 136.59. Where again, you had been paying $150 each month. Okay. Now, how much did you actually pay for the snowmobile? So this is kind of the sad part. What people think when they take out a loan, they're like, yeah, I'm just taking out a loan. My snowmobile was $4,200. That's all I paid. Well, no, you didn't pay that. You paid a lot more than that. You made a lot of $150 payments. You made 29 $150 payments, plus you made one payment of $136.59. Okay, so if you do that, and you can use Google Sheets to do that as well pretty easily. Just grab a cell, hit equals 150 times, what was it, 29? Oops. Plus your 136, what was it, 136.59? So you actually paid that amount. So not too bad, really. You actually paid $4,486.59. Or $486.59. So not terrible. The last question then is how much did you pay in interest? Well, that's the difference between what you actually paid and what the snowmobile was worth. So you actually paid $4486.59. The cost of the snowmobile was only $4,200. So you paid this one by hand. You paid $286.59 in interest. So not terrible over the course of those 30 months. If you're buying a house, don't even do the math because it's depressing. I did it, and it's not pretty. But for something kind of small like that, a loan isn't the worst thing ever. So what you want to do now is go ahead and do the recursion worksheet. Complete that, check your answers. They're on Schoology, work with each other, ask around if you need to, and then you'll be working on your project, which is similar to the word problems, but doing your own situation on Thursday and Friday this week. So hopefully that's going okay for you guys. I'll see you in a few days.